long weekend. But then, so we'll resume on March 6th with lecture 3 and lecture 4. Sorry. So lecture 1 is supposed to today. 3 and 4 is 2 weeks later, and so on. So basically, there's not really much to really go through, but so the whole structure of this course I already announced at the beginning of the first class, but I will repeat it now. So there will be one final exam, 50% during the final week, and then there will be weekly quizzes. We'll take the top 10 highest scores of that you achieve, and it will count for 5 points each. And so for all of the class time, so you watch the videos beforehand. The class time, the first hour will be office hour. I actually already uploaded the notes of the first office hour early on NTU Cool. So if you go there, you'll see it. And then the second hour, the second class will be the quiz. And so we follow the bell. I'm not sure how many people will stay in this class. But if it's the same amount, like as you see here, then I think we will keep using this classroom for the quiz. But if we only have like 5 or 10 people, then next time, then of course I think using the smaller classroom that we were assigned to is a better idea. So we'll see. So yeah. So I requested this classroom for quiz 1 because I know that there could be a lot of people, and I think we should still meet at the official classroom next time. But again, so if we have too many people, then we will move to a bigger classroom. And of course, I think after week 3 and week 4, then eventually we will see how many people are left. So yeah. So if we have the same crowd as we have today, I think we will stick to this a classroom like this one. Hopefully this one. I don't know. I mean, it depends on which classroom that the college will give us. Yeah. And then so the first hour is office hour. So if you have any questions about the video that you watched, then you should ask at that time. Otherwise, the TA would try to summarize some of the important, or highlight the important parts that he thinks is important. You actually saw some of the questions that are closely related to the exam questions that were revealed. So that's how important the office hour is. And then the next hour will be the quiz, and the last hour will be explaining the quiz, the solution of the quiz. Although the TA has already uploaded the solution of quiz 1 onto NTU Cool. At least I can see it on my part when I log into NTU now. So I think you guys should also be able to see it as well. And so for those who have, so how many of you did not attend the office hour and came in before the quiz? Yeah, so some of them, okay, yeah. So I wanted to explain that. So the purpose for this course is to help people to pass the math camp for economics graduate school, for the master's and PhD program, because so we used to have a 3-week course before semester starts, right before fall semester. But the students were very frustrated because they can't learn the material in 2 or 3 weeks. The instructor is also frustrated that the students are frustrated. So we decided to say that, okay, maybe especially if you are admitted into the master's program in the fall, you might as well take this course and prepare for that. Yeah, so that's the goal. But because of this, as I state in the syllabus, this course cannot substitute for the math department course that has a very similar name. That course has 5 minutes. This one has only 3. So this is not a substitute. But this is more like an online course that So the class time is not really to teach you anything. The real lectures are to watch the video. Yeah. And I think the second announcement I wanted, somebody asked me if the video, about the video quality. Unfortunately, the videos were taken like 8 years ago, so or 9 years ago. So the quality is not good, but Francis, who actually has on his blog his lecture notes that are of high quality. So you should look at those lecture notes if you find his chalkboard writing not clear enough in the video. And of course, there's also the Nietzsche's OpenCourseware. He uses the same textbook, Rudin, although he follows his own order, so it's your choice. All right, so what else did I miss?
The grading policy of a gap.
Oh yeah. So we have this. So supposedly 50% is the final exam, 50% is the 10 quizzes. So each quiz counts as 5 points. But we have a special rule that that if you need to take the quiz online, this mainly could happen, especially if you are under quarantine, because there's always this danger. But also, I mean, if you want to take this entire class online, it's also possible. But anyway, in any case, so if you can't make it here for whatever reason, you can take the quiz online. So the TA would have to open up, like say, WebEx or Google Meet to proctor you online. But in that case, that quiz will count only as 1%, if it is the top, the highest, and the remaining 4% will be replaced by the final exam. And of course, what's not written here is what happens if the final exam has to be taken online. I think the university actually has a standard procedure that if you cannot take the final exam, you need to file for a leave of absence, and it will be approved by the university that we will do an online final exam. But that's not written here because if that happens, then you'll have to follow whatever is the rule of the university. And yeah, and so I don't need to state that here. Okay, so the office hours of the TAs are not listed on the syllabus. I'll tell you that, but it's written up there. Okay, so
if you cannot make it, just give us, and we can like do the office hour by appointment. Another thing is that in this course, our grading policy is not does not follow the percentage you have obtained. Like there's no something like, oh, I got 90% of the score, so you get A+. It does not work like that. We use gaps to cut it into the grades. So like it would be like if everyone's grades is like 98, 98, 97,
are you sure you're going that?
91, and 80, like it's 84. Then there's another gap, let's say 78, and we'll cut it like A+, A minus, something like that.
Okay, yeah.
Not follow exactly the grade.
Sorry if you have not noticed. If you look at quiz 1, so quiz 1, the total number of points for quiz 1 is not 100. Hey, don't erase that. I wanted to show you that.
Okay.
Yeah.
97,
So
97.
yeah, so if you look at the total points on quiz 1, it sums up to not 100. It sums up to how much?
138.
138. So yeah, so we are deliberately not following the 0 to 100 rule, but instead, so it'll be like 138. And so what that means is that suppose at the very end, so the final grade distribution looks like this. So there are 98, 97, 97, but then there's nobody between 97 and 92. Then we will actually cut the letter grade cutoff at that place. So what this means is that if there's a huge cluster, then all of those people will have the same grade. But yeah, but there is no one-on-one mapping of if I score 95, then I should be A plus. If I score 87, I would be A, and so on. Yeah, and of course, because the total point is 138, so scoring 95 out of 138 would definitely not earn you an A plus. Yeah, that's for sure. Yeah. Yeah. So one thing I want to explain is that the reason why we want to use this gap method is that this minimizes the mistakes how mistakes would affect your letter grade. I mean, because if you are down here, and because the TA sort of marked your exam incorrectly, even if the TA corrects that mistake, it's very unlikely that you will move up to up one letter grade or down one letter grade. Yeah. So we want to minimize the effect of possible mistakes. Yeah. But of course, I mean that also means that the distribution of the letter grade will depend on the distribution of your scores, which of course we cannot predict. Cool.
Let's do some our quiz. I hope this quiz is not too hard. Is it too hard? Cool. Okay, so
Someone told me before the last week that he believes that people can finish this in 15 minutes.
50 minutes.
15 minutes.
Okay, 15 minutes. Yeah, maybe. I'm not so sure if that one is too hard for you, but it seems not. Okay. The following quizzes will follow the same fashion of this quiz. So there will be some question about definition, some question about like basic operation of definition, and some questions from the video, and the final question would be a little bit harder than the previous ones. So that one is the kind of A plus questions. Okay, I'll do questions 1A. R is the relation between sets and A and B. So 1A, we expect you to write something like R is like something like this. Or R is a subset of this one. And B, we expect you to write something like this is an order, it's a relation. S, or of course you can write alternatively and satisfies, which satisfies just like this. Everything like this will be accepted. If we write things like this, we'll get 4 points. So it will be 30 points. Like this. And the second question. Can you see here if I write it here or should I erase? Should I erase it? No. Okay. I need some feedback. A equals to 1, 2, 3. B equals to intersection would be asking which element lies in both sets. So it would be 3 only. And A union B should be equals to 1, 2, 3, and 4. Right? And A minus B be asking which element only lies in here but not here. So that would be 1 and 2. And A times B would be, seems like A, B, right? A, B, A, B, B. So it would be 1, 3, 2, 3, 3, 3, 1, 4, 2, 4, 3, 4. Any questions? No? Okay, let's move on. How do you define it? Intuitively, how we define it? Pretend that you haven't like go through a course. What do you think it is? It should be AD plus BC over BD. Right? It should be natural. So how do we prove the following sentence? If A over B equals to A prime over B prime, C over D equals to C prime over D prime, blah, 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 blah. So what we're doing, I use yellow pen. So intuition. We're saying that these, what we're trying to do is, I want to say this one. I want to show. And turn back to the definition. Always remember the definition. Let's remember what's the definition of equal. What's the definition of the equal between rational numbers? That would be AD plus BC times B prime D prime equals to A prime B prime plus B prime C prime D. This one is definition. That's what we want to show. And what we have is A over B equals to A prime over B prime, and C over D equals to C prime over D prime. What these equations gives you? It gives you a definition. A B prime equals to B A prime, and this one by definition, C B prime equals to DC prime, or A prime B over C prime B. This also by definition, right? Definition. So what we're trying to do is using these to obtain this. Right? So let us do some observation on this. That would be, this one would be A, B from B, B from plus B, B from C, B from. This one would be A from B, B, B from plus B, B from C from B. That's the difficulty here, right? So what we are trying to, let's just observe these two terms. You'll see these two are the same, and these two are the same. And another thing you can observe is this one is A from B, CD from C from D, just connected together through these. Right? So that's the intuition. I'll write it formally. Can I erase that? Okay. So, by definition, all A over B equals to A from over B from C over D equals to C from over D from. We have that A B from equals to B A from, and oh sorry, I should write A from B. C B from equals to C from B. Moreover, this C from D from gives you AD plus BC BD equals to A from B from plus B from C from B from D from. So by definition, it will be AD plus BC B from C from equals to A from B from plus B from C from BD. B from BD from plus B from CD from equals to A from B from B plus B from C from D. However, A B from equals to A from B gives you A B from B D from equals to A from B D D from. And also, C D from equals to C from D gives you A B D from C D from equals to B B from C from D. So, these two gives you this. Alright, I'll just let it forget it. And so that's the end of the proof. So, like from this example, if you stuck on this question, when you're doing quiz, always think about two questions. One is what I need to show. So what do I mean by A over B plus C over D equals to A prime over B prime plus C prime over D prime? What do I really mean? What's the formal meaning of this statement? And the second thing you need to ask yourself is, so what I have now? So in this case, you have these two. So by definition, what do you have? By definition, is there anything you can use? So by definition, you have these. You need to show this one, and by definition, it's this one. If you obtain these two equations and this one goal, then I think the path is like clear if you can do all these things. Right? This one is straightforward. Once you can like notice this goal and this element we have. That'll be a tip when you do math. Just like ask yourself, okay, what do I have now, and where am I going to? Okay, let's do the fourth question. Do you need more data?
Yeah, I have one question.
Okay.
So why, so what's the difference between A prime and B prime versus A and B? So, I mean, so A and B are,
A and B are integers, and A prime and B. So let's get some examples.
yeah, but I mean,
Okay,
but
3, 4, 6.
yeah, okay, yeah, so I mean, so that means that, say, A prime, B prime would not have would have common divisors.
Yeah.
Okay, I see. Okay, now I understand why I was confused, because I thought it was unique.
Okay. So the representation is not unique of the rational numbers, I think. Okay, so let's move on to the fourth. By fours, S would be x squared equals to 12. And a simple way to do it is by, I forgot to look it over when you're in quiz, but by 牛顿一次性是减法，x squared minus 12, so it's way 1 equals to 0 as possible rational roots. But none of these solves the equation. That would be one way to do it. And of course, there are ways to. So as usual, we assume x equals to p over q. So we have that p squared equals to 12q squared. All right, so let's observe p and q, just as we have observed in 2. What can be? What can divide p? 2 and 3, right? So we know 2 divides p and 3 divides p, which means that p equals, of course, here, pq in z, and pq has common divisor of 1, common setting. P equals to 6p prime, p prime in z.
So hence 36 p prime squared equals to 12 q squared, which means that 3p prime squared equals to q squared. That gives you 3 divides q. So for now, 3 divides p and 3 divides q, which means that p and q has
the greatest common divisor of p and q is not 1, which leads to a contradiction. That's a usual way to do it. Can I reset? Cool. So the fifth.
We want to prove that if x is not equal to 0, then s squared is greater than 0.
Again, what we have. What we have. Just observe the question. What do we need? What are the elements in this question?
There is some, what do we mean by x squared? X times x.
So maybe we need some properties of multiplication in order field. Okay? So what do we have in order field?
We have some property or axiom of ordered field. We have if A is larger than B, x larger than 0, then AX larger than BX. We have this one.
So can we make use of this one? Just observe the thing that we need a condition that x is greater than 0. So maybe we can first do it when x is greater than 0. We split the question into 2 parts.
Right. So I'll do the intuition here, and I'll do the proof here. So the proof. By, okay, no. That x not equal to 0 means that x is greater than 0 or x is less than 0. But suppose x is greater than 0.
So what you want to do, maybe, like plug x, multiply x in 2 sides.
X squared over x.
And this one is 0. We have shown it in the first period, so I will not do it again. So this one is done.
And how about x less than 0?
So think about what do we mean by squared by x less than 0, or how do we relate it into the positive things.
So maybe there's an observation.
Not that easy, but I think you have experienced that
X squared equals to negative x squared.
think you know this property, right? So how about we've done this together. Why x squared equals to negative x squared? Okay, what is x squared? X times x. What is negative x squared? It will be negative x times negative x. So how do we connect these together? We have multiplication, we have negative. It's somehow like, it's a hint for us to use distribution law. Right? So we can do it in this way. X squared plus x times negative x. This one equals to x times x plus negative x. It equals to x times 0 equals to 0. For the other side, negative x squared plus x times negative x equals to negative x plus x times x equal to 0x equals to 0. So these two are the same. By cancellation law, x squared equals to negative squared. Right? So let x less than 0, observe that x squared equals to negative x squared. And with proof here, okay? Proof for the proof, just move this here. And the second part is what? We want to say, okay, why we need this equation? It's because like we hope this link will lead us to the first part, right? So somehow we need that negative x is greater than 0. Moreover, x is less than 0, which means that x plus negative x less than 0 plus negative x. This one is 0, this one is negative x. And negative x greater than 0 by this part. So we know x squared equals negative x squared, and negative x is greater than 0. So by the first part, negative x squared greater than 0. Proof is over. So the fifth question is like a little bit harder. You need to like come over how to deal with this this kind of thing. But it should not be too hard to understand if you like go through a whole proof. Okay, since the time is almost over, I think I recommend you to like finish the book, the reading, and also the problems. Right. If you have any problem doing with those questions on reading, just come over when office hour. Yeah, anything want to talk about? If not, thank you.